Good day, and welcome to the Control Engineering webcast, Getting Started with Enterprise Industrial Data Collection, sponsored by PTC Kepware. I'm your moderator, Kevin Parker, an editor with CFE Media and Technology, joining you today on behalf of Control Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for our speakers in the same Ask a Question box. The live Q&A session begins after the presentations conclude. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion, a PDF copy of the presentations, and additional resources, use the Event Resources tab on the left-hand side of the screen. These documents will also be available with the on-demand version of this webcast. I'm now happy to introduce today's presenters, Ray Levy, Jeff Bates, Neil Hagermusser, and Carl Schweitzer. Ray Levy is a Principal Applications Engineer at PTC with a focus on Kepware industrial connectivity. Ray joined Kepware Technologies in 2014 and came to PTC with its acquisition of Kepware in 2016. His previous work experience is in the shipbuilding industry. In all his work, Ray combines technical expertise developed over 15 years in network control system integration with an unbridled enthusiasm for engineering. Neil Hagermusser is a lead within the solution organization for PTC. For 3 years, he has been the technical lead for PTC's strategic partnership with Microsoft. Coming from a hardware and firmware background, Neil joined PTC 5 years ago as an original member of PTC's IoT team. As the technical lead for the Microsoft partnership, he works closely with both R&D and product management to ensure that the solutions developed will best serve their customers. Neil often can be found in the field around the globe working directly with joint sales teams or training new account teams on the value of joint offerings. Carl Schweitzer of Microsoft is a senior software engineer, and he works with some of Microsoft's largest partners, advising and enabling them to build new products and features to the cloud. Carl has 2 decades of experience in manufacturing and over 10 years of experience in building IoT applications. In addition to his professional experience, Carl speaks at local and regional software engineering conferences, runs local user groups and code camps, and volunteers to teach computer science at the local high school. Finally, Jeff Bates leads product marketing for Thingworx portfolio of edge and connectivity applications, including Thingworx Industrial Connectivity, KepServer EX, and other Kepware products, the Thingworx Edge microserver, and the Thingworx Edge SDK. Jeff works closely with end users, partners, and industry experts to develop relevant, high-impact messaging on the value of Thingworx connectivity solutions. Prior to this role, he consulted with leading manufacturers, helping them define growth strategies and tactics. Jeff received his MBA from the Darden School of Business at the University of Virginia. Jeff, welcome to today's webinar, and please go ahead.
Great. Thanks very much, Kevin, and thank you, everyone, for your time. Today, we want this webinar to be very hands-on. We want to show some specific examples of how to get started with enterprise industrial data collection. But I do want to start by giving a little bit of context around why we think this is important. And so the best place to begin is really by acknowledging that connectivity for digital transformation or Industry 4.0 is really difficult. And the reason we think that's important is that we're seeing many companies that are tasking their CIOs or IT organizations to implement digital transformation, or at least start out with a pilot. And oftentimes, coming from an IT background, these individuals have, sometimes preconceived notions about how enterprise data is collected and what that process will be like. So if you are one of those individuals, I want to take this opportunity to make sure you're going into this project with your eyes wide open. If you have more of an operations background, or if you're a controls engineer, you likely understand a lot of this. But I hope that this is a framework that you can use to help those in your organization without a background in controls to really understand the nature of the challenge. So to dive right into it, let's compare IT data, or the type of data that enterprise projects have relied on in the past, to OT data, or the type of data that Industry 4.0 projects require. So first, let's look at the state of the data. IT data is typically stored in a database, most likely a SQL database where you're storing customer transactions or employee data or something along those lines. You can contrast that to OT data, where the data coming off a PLC is real time. If you're not capturing it when it's created, then it's gone forever. On the other hand, you can't capture all of that data and just drop it into a SQL database or even a time series database, because some of that data is changing at every 100 milliseconds. The factory is awash with data, and your storage bill would be astronomical. So you still need to store a lot of that data, but you need to be very smart about what data you need when and how it rolls up into critical KPIs. So moving into context, IT data sometimes by its very nature has metadata. In a SQL database, you can have a huge number of columns so that each data point has a significant amount of data associated with it that you can query. Just to give an example, a transaction might have an amount associated with it, a timestamp, an account, an address, all associated with a single data point. With OT data, oftentimes you can be lucky if you get a timestamp and a value with no additional context. And I'll say that this isn't universally true, but in a lot of cases you may not even get a data type without talking to a controls engineer. And I think the best example of this is with the Modbus protocol, which is really used everywhere. It's present in most facilities or production environments. And with Modbus, you really have to know the data type going in order to read the correct registers. And we'll go into that a little bit more, but we haven't even started to talk about, the more what others think of in terms of context of data, just in terms of, this Boolean represents whether or not this machine is on or off, that machine is on this line, which makes this kind of parts, which are part of this type of products. You're not even getting into that piece of it. And there's certainly work being done to get closer to delivering all of that metadata with a single data point. But on most legacy machines, that is going to be completely up to the user to figure out. Really, all you're going to get from the controller itself is raw data and timestamps. And just lastly, I want to talk about the data model. With IT data, it's all symbolic. And what we mean by that is really that that dollar amount that comes through with a transaction in a SQL database is in dollars. And that could be such a simple assumption that you don't even think about it. How else could data possibly be presented? But there are certainly many controllers out there today that allow for symbolic addressing, that allow you to associate at least a name with a data point. But there are many legacy controllers. Again, Modbus is a good example, where everything is still register-based. That goes back to the example before. You need to know that registers 40,000 to 40,003 have been configured by the controls engineer to hold a variable that's a long data type. Because if you just read register 40,000 as a word, it's not going to mean anything. And of course, all this refers to directly connecting to a Modbus device. There are many tools out there that make this easier. But the reason I bring all this up is that we've seen many companies and many IT departments decide to go after Industry 4.0 or digital transformation using very low-level tools. For example, a Modbus SDK, where you would need to understand these types of things. And so if talking about registers and data types and all of those pretty nitty-gritty things has started your eyes have started to glaze over, and you're starting to regret the level of detail that we're going into, then you really want to keep listening, because using tools to get started with enterprise data collection is going to help you avoid having to learn all these nitty-gritty details there'll be tools that present you or really provide you with a layer of abstraction. And so that's what we want to talk about today. So that was sort of the gloom and doom side of things. Is why it's difficult and why oftentimes it's more difficult to collect this type of data than the individuals who are responsible for it might think. But there are plenty of tools, even though folks are going after Industry 4.0 with internally built tools. There are third-party tools that can make a lot of this easier. And I think it's important to note that there I didn't say easy, I said easier. There's still plenty of work involved here. We didn't even get into things about networking and security, but doing it all with tools that are built in-house, which is what some companies are tending towards today, that is so difficult as to sometimes border on crazy. So specifically today, we're going to talk about some of the technologies that can make all this easier. And what we're seeing lots of companies use is a public IoT cloud. And in terms of the challenges listed on the previous slide, an IoT cloud can offer solutions for data storage that make accessing the right data at the right time much easier. I mentioned security. It can manage all the security required for that data transfer, since production data is critical to the functioning of your company and to its value proposition. So that's a key piece that I think we even got some questions on before the webinar. Public IoT clouds can help you create a framework for what data and what processing needs to be available, or what processing needs to happen within the factory, and then what data can go to the cloud to be accessed across all factories. And additionally, these IoT clouds are especially useful when combined with a connectivity tool that allows you to abstract away some of the considerations I mentioned on the previous slide in terms of data type and some of the protocol specific nuances. The combination of these two technologies allow you to create an environment where by the time you're passing off the data to someone who's actually building an Industry 4.0 or IoT application, that data has the context that it needs to be useful and can just be picked up and used in an application. So again, I want to highlight that we're not saying this technology allows you to push a button and immediately see beautiful dashboards that convey critical insights about your production all automatically. But it can manage some of the things that have been proven to derail Industry 4.0 projects, like storage, like security, like data access. So let's dive into the technology itself and take a look at how it makes this all possible. So again, from a technology perspective, we want to give you a sense of what is a public IoT cloud. And the first two bullets here really get to the heart of it. An IoT cloud is a managed service in the cloud that enables data transfer from your factory or production environment. Importantly, these solutions are scalable and secure. They enable you to use the data in cloud services, again, in creating those IoT or Industry 4.0 applications. We won't dig into the device management capabilities too much, but they also have impressive device management capabilities, which is an important consideration when deploying these types of solutions. And just to put a finer point on it, the three most popular IoT clouds that we've run across are shown here. And today we're going to focus on Azure. That is really the public IoT cloud that we've seen used most often in industrial environments or Industry 4.0 projects. So as I mentioned before, these solutions are particularly useful when they're combined with a connectivity tool, and we want to talk a little bit about why that is on the following slide here. So public IoT clouds today natively consume data over MQTT or some flavor of MQTT, and some have developed tools for ingesting data over the OPC UA protocol or Modbus. But in most production environments, there's a gap there. Production environments have all different kinds of controllers that may or may not speak OPC UA or MQTT, Mitsubishi controllers use Melsex, Siemens controllers use their own proprietary protocol, Allen Bradley controllers use the Common Industrial Protocol, the Common Industrial Protocol, and sensors and scales may use any number of things, including just a simple ASCII protocol. So the options for connecting all of those disparate devices to the platform are what we show here. And all of these platforms offer an SDK for connectivity. We've already covered some of the drawbacks of building your own application for connectivity to all these disparate devices. It really boils down to maintainability as well as really needing to understand the low-level protocol very exhaustively if teams are going to build that application in-house. So there's also the notion of using a hardware gateway. There are a number of drawbacks there, including that you're introducing additional device management challenges. Anytime an additional device is added to the network, there is networking challenges, security challenges, just one more device to manage. So, and of course at PTC Kepware, we're certainly biased, but we've seen a lot of companies be very successful with a software gateway. Those software gateways can be installed on pre-existing hardware. There are software gateways that can connect to almost any controller, and in a lot of cases, these software gateways are potentially already being used in your organization to connect SCADA or HMI or an MES or historian or other application. So because we want to dive into a real-world example, we do want to introduce the software gateway that we'll be using in this case, which is Thingworx Kepware Server. So just to start out, for those of you who are already familiar with Thingworx Industrial Connectivity, we've renamed that product to Thingworx Kepware Server, really just to highlight that it's built on Kepware technology. And for those of you that are familiar with KepServer EX, Thingworx Kepware Server is built on the same technology, has the same features and functionality, and really will be the product that we as PTC use to drive connectivity for Industry 4.0 moving forward. We will continue to offer KepServer EX, but we will use Thingworx Kepware Server to really help advance customers in their digital transformation journeys. So for those of you who aren't already familiar with either Thingworx Industrial Connectivity or KepServer EX, we'll introduce it here. We'll introduce Thingworx Kepware Server here. It's a software gateway that connects to virtually any controller or machine in a production environment. And as we'll show in subsequent slides, it has seamless connectivity to popular IoT clouds. The code base is trusted in over 75,000 sites. It's been developed over the course of 20 years and is likely being used in at least some of your sites today. So while there are a number of software gateways out there today and even a handful that enable connectivity to public IoT clouds, for the purposes of the webinar today, we'll be using Thingworx Kepware Server. And as I mentioned, in the customers that we're working with, we're seeing Azure deployed in these factory or industrial environments, more so than any other IoT cloud. So we really want to dive into a discussion with that background of how to use these technologies, Thingworx Kepware Server and Azure technologies, to begin to collect data at enterprise scale as part of an Industry 4.0 or IoT implementation. So in order to get started there, I will pass it off to Carl Schweitzer of Microsoft to introduce the different Azure components that we'll be working with or that can help you get industrial data into Industry 4.0 or IoT applications.
Thank you, Jeff. The first component that we're going to talk about is Azure IoT Hub. This is the premier platform service to work with IoT devices and get your data into the cloud. First and foremost, it doesn't matter if you have one device that you're building and testing, or if you have billions of devices that are deployed worldwide. You can use the same tooling and the same skill sets to develop your software and manage these devices. The security is built in on from every aspect. You can use per device tokens that are generated at the cloud. You can use enterprise security certificates that you get from common certificate authorities. And you can also have that security baked into the TPM chips of your devices. Azure IoT Hub works with all of those different common security scenarios to make sure that your devices and your data are encrypted at transit and in rest. In addition to making sure that your telemetry and messages get to the cloud, there's also bidirectional support of communication between your device and the cloud through IoT Hub. The devices communicate over both Microsoft specified protocols like AMQP, but also as common industry protocols like MQTT. There's also REST and the ability to run both of those protocols over HTTP web sockets. To develop custom applications with IoT Hub, there's many open source SDKs out there that support a variety of languages from C++, Python, Java, JavaScript, and our own C#. Very versatile, and if you do have feature requests, they are open source. There's issues on there that you can open up, and Microsoft engineers will enter those into our own backlogs and help make sure that these SDKs fulfill the requirements of building IoT solutions. And in addition, Azure IoT Hub really integrates well with Thingworx and Kepware technologies for a seamless integration of existing IoT solutions as well as creating new ones. The next component in Azure is Azure IoT Edge. Azure IoT Edge is a platform that can run on your device to allow localized workloads. These workloads can be containerized services that you've developed on your own, or they can be additional Azure services that are optimized to run locally. These things can be local storage that has the same API interface as blob storage. There's SQL containers, Cosmos, Redis, a variety of others that operate exactly on the edge as they do in the cloud. The importance of this is there's a lot of times that just the latency of getting data to the cloud takes too long to process the data, create an action item, and actually interact with the result of that. Being able to have these workloads at the edge gives us the ability to more quickly react to things. In addition, some of these workloads, like machine learning, take data that would take too long to send up to the cloud. So if we can operate on a massive amount of data locally, then what we can do is we can simplify and only send the results up to the cloud where need be. So this gives us quite a bit of different capabilities than we had in the past without IoT Edge. Once again, IoT Edge works with IoT Hub to install and make sure that these containerized workloads are running, they're up to date, but more importantly, they also work when these devices are completely offline or have intermittent connectivity to the cloud. These containerized workloads are Docker compatible, and many open source modules can be deployed and operate on IoT Edge. And lastly, the last component that I want to talk about is the OPC Publisher, or the industrial IoT platform. When we're looking at manufacturing scenarios, a lot of times we're working with systems that have been in place for a long time that include OPC UA servers. what the OPC Publisher and the Industrial IoT gives us is it gives a way to natively interact with these OPC UA servers using the existing OPC UA specification and send data telemetry to the cloud over IoT Hub without changing the data format. This is fully capable across all of the specifications. So you get things like publisher and subscriber, you get custom UA methods, it supports batching as well. And once again, this is all without transforming that data and adding inherent latency or processing to the workflow. And I believe that next we're going to talk to Ray about how to integrate with IoT Hub.
Yeah, absolutely. Thank you, Carl. So as an application engineer, I've been working with our customers that are looking at this journey of leveraging newer technology and cloud platforms such as Azure. And so I get a lot of questions about what's the appropriate way, or what's the best way I can configure my OT data from Kepserver or Kepware and be able to provide that information into Azure's IoT infrastructure so that it's easy to leverage with the applications that you would be building or tools that you'd be using to consume that data from the Azure IoT Hub infrastructure. So what I wanted to do is lay out the three options today that we have available with the Thingworx Kepware server tools and Kepware technology, and the combination of the IoT Hub and IoT Edge modules to get data into your Azure infrastructure and be able to leverage that in your enterprise. So the first option that we've done integration with for customers has been taking Kepware and connecting it directly to the IoT Hub infrastructure using MQTT as a transport layer protocol. And this has been very successful for a lot of reasons, but I want to highlight some of the features and functions and pros of why this is, how you do this and why this is possible. So the endpoints that are available, the inputs to the IoT Hub can be configured by building out your device model within your IoT Hub infrastructure to help model the assets or the PLCs or the machines that Kepware would be connecting to and consuming data from. So you would set up these connections with Kepware's IoT agents to be able to make that integration and help flesh out the model between Kepware and the IoT Hub infrastructure. And this is a great connection and integration because it allows you to model the data set as it's coming into the IoT Hub. So it simplifies processing the data at your higher level applications, as well as provides good bidirectional data to connect between your applications and Kepware and ultimately the industrial data sources that you're connecting to. So not only can you read and consume data, you can also send commands and configuration data down to those PLCs devices. And the last sort of benefit behind this type of architecture is being able to configure and connect to this without any sort of external configuration beyond the IoT Hub and the Kepware instances to be able to integrate natively. Going on to the next phase, what we look at is option number 2, and this is getting into a little bit more of a complex example, primarily because the use cases around this are that the IoT Edge and the capabilities that Carl was highlighting earlier might be beneficial for your particular applications. You might have other data sources that You might be pulling information in from your IoT Edge module. You might have containerized processes doing edge processing of the data that's coming from these edge sources, such as Kepware and other systems that they might be connecting to. So you might want to leverage that modules, those modules available in the IoT Edge, or build out modules in the IoT Edge infrastructure so that you can process data locally and then be able to send the information as necessary up to your IoT Hub infrastructure as well and build out your cloud-based applications on top of that. So in this application or this option, it's very similar to the first option where Kepware would be leveraging the MQTT agents to help build out and model that device infrastructure so that the hub and the edge see that model natively based on the data that's coming from Kepware. Some of the additional features it does provide is that you can essentially multiplex the data from your factory or from the edge and provide it to your cloud infrastructure. So the edge will take the multiple connections from Kepware and be able to aggregate it into a single connection, but still keep the model of the data as it's being presented. Some of the other features that are available in the IoT Edge runtime is that as a transparent gateway in this configuration, it can also be leveraged to do local storage and buffering of any telemetry or data change information at your factory or the edge, and provide that up to your cloud-based infrastructure once connections are reestablished due to any sort of network latency or network outages that you may have. So it can sort of add robust capabilities on top of keeping that simple data transformation or data model infrastructure that was built out in option 1. And then finally, I'd like to highlight the third option that customers and end users have available to them is leveraging the OPC UA Publisher module. This is a module that's available to run within the IoT Edge runtime. And because OPC UA is very ubiquitous in the manufacturing space, we get a lot of questions about leveraging this module as well instead of leveraging the MQTT interfacing that Kepware does provide and have support for. So I like to at least highlight and talk to this solution a little bit. It does allow you to connect directly to the built-in OPC UA server interface that Kepware has today. So this can also provide you very quick connectivity to get access to that information. Some of the challenges customers often have are typically around setting up this publisher module. It's very much a process that you have to either script or build out. It's a little less straightforward in the configuration as it is today. I know Microsoft is certainly working to extend capabilities as PTC and Microsoft are working together to build out a good integration between these applications. So while there's a little bit of challenges behind it, it can be a super easy and useful way to quickly get data from Kep server or Kepware and provide that data into the IoT Hub with some quick, as Carl said, keeping the data formatting as it is within the OPC UA server, and then being able to use that information model within your higher level applications today. So if there's something to take from this, there's really multiple ways to integrate the data between Kepware and Azure's IoT Hub and IoT Edge infrastructure, and it really is going to depend on the different use cases and requirements that you may have within your use cases as well. So it's certainly good to evaluate each of these and compare them against the requirements that you have within your projects or solutions. So now let's talk a little bit about what you can do with that information once it's in the IoT Hub. So I'm going to pass it on to Neil, and he'll talk a little bit about leveraging Thingworx as a application and using this information that we're providing. So Neil, go ahead.
Great, thank you, Ray. Hello, I'm Neil Hagwasser, technical lead supporting the Microsoft partnership for PTC. So, as Ray mentioned, I'm going to talk briefly about the Thingworx platform itself and how to actually leverage that data when it reaches the enterprise cloud. So, Thingworx is an IoT application development platform that's deployed on Azure. It's a full-feature application development platform designed specifically for the industrial settings. It is building blocks allowing you to connect your data and add context to that data, to build out your custom applications, to do machine learning, to manage the complex workflows that often are happening in these industrial settings, and to experience the data through an interactive UI. So on top of that, Thingworx also has accelerator applications. So these are built to be configured applications that sit on top of the building blocks, and they're designed to help specific factory use cases like asset information gathering and operational intelligence, and help jumpstart your development and your customizing of your applications for your specific use cases. All of this leverages the Azure IoT platform underneath, from core IoT services like IoT Hub and IoT Edge that Carl mentioned before, to pre-built connectivity to other Azure services like Azure AI, Azure Data Storage, while sitting in an Azure IaaS environment. So when Thingworx, PTC, and Microsoft are working together, and the advantages you see is a faster time to value. So our customers are able to leverage both PTC's deep industrial expertise on the enterprise cloud. We have a joint roadmap development that Ray has touched upon, doing lots of work on the OPC UA connector, making sure that we have much better operations across our overall roadmap of our IoT solutions. And then we bring together a best-in-class partner ecosystem to truly extend what we can do with each other's technology and help our partners succeed faster. So I want to briefly touch upon this architecture, and then we will go into the demo. So when you're actually connecting Thingworx to Kepware data when using Azure IoT Hub, this is the architecture that we would go with. There's very similar to the first architecture that Ray showed before, but what we're adding here is we're adding the Thingworx IoT Hub connection server. This IoT Hub connection server handles all the communication between the Azure IoT Hub and the Thingworx Foundation server. It does the translation out of IoT Hub device twins and telemetry messages into the Thing model. And this allows you to add the additional context once it hits the Thingworx Foundation that would actually allow you to see the benefits of connecting your edge assets and bringing that data to the cloud. So what you'll see next is a demo video that highlights and gives an example of how you actually would set up that connectivity, and it actually demos a Thingworx application.
This demo will show the basics of getting data from Kepware flowing into Thingworx to Azure IoT Hub. For simplicity, I have already configured the Thingworx server, Azure IoT Hub, and created an Azure IoT device. I have here Kep server running a sample project that includes simulated machine data. In this demo, we are going to connect Kepware to Azure IoT Hub using the IoT Gateway. First, we will create a new agent for the machine data that we want to send to the cloud. We will give a name to the agent to distinguish it, and we'll need to change the agent type to MQTT. We now need to configure the agent to our Azure IoT Hub. We are going to connect this IoT Gateway agent to our already created Azure IoT Hub using the already created IoT device. We'll need to set the URL and topic. The URL is specific to the IoT Hub, and the topic is specific to the IoT device. The other settings can stay at their defaults. We are going to set the client ID, username, and password. The client ID is just the Azure IoT device ID. The username is a combination of the IoT Hub name and the IoT device name. And the password is the SAS token for the IoT device. On Kepware.com is detailed documentation for the configuration of the IoT gateway, including instructions on using certificates rather than SAS tokens, and using the Kepware REST API to configure the IoT gateway. Now that we've configured the IoT gateway for communication to the IoT Hub, we need to add the tags that we want to send, understanding that all tags that are sent over this IoT gateway will be associated to a single thing in Thingworx. Let's just select 2 tags and add that to our IoT gateway agent. We can keep the default scan rate and deadband. After the tags are added, the IoT gateway, it will connect to the IoT Hub. You can see the successful connection down the logs at the bottom of the screen. This indicates that data is now flowing into the Azure IoT Hub. This is the Thingworx Composer environment. It is the editor for Thingworx applications. We are looking at the Thingworx thing that is corresponding to the Azure IoT Hub. From here, we can trigger an import service that will input the IoT device that is on the hub and create the corresponding thing in Thingworx. We need to supply the thing name, which is the same name as the IoT device in Azure IoT Hub. We also need to supply the Thingworx template, which for things imported from Azure IoT Hub would be Azure IoT Thing. The last thing we would want to select is the thing shape. This is the thing shape is custom to your device and handles the parsing from VQT JSON array into the thing model. Now looking at the newly created thing, we can see our tags from Kep server are now properties on our thing model and are getting updates. Now that data is flowing into our thing, it can be used in a Thingworx application. Here is a Thingworx manufacturing application that would run in the cloud that is looking at metrics from various plants that would leverage data from Kepware flowing through the IoT Hub into Thingworx.
Great. Thanks very much, Neil. So just to give a quick recap, we want to be sure to leave plenty of time for questions. But as I said at the beginning, collecting enterprise industrial data is difficult. We haven't talked about the benefits of doing so, but we've seen companies across industries, the majority of companies, in the manufacturing or production space, starting to at least experiment with Industry 4.0 or IoT, and the value is moving away from some of the 1 to 2% improvements of continuous improvement programs, and moving really towards transformative value, huge improvements in productivity, reduction in scrap, increase in revenue, decrease in cost. So, and we found a number of companies today are moving from the conceptualization or goal setting stages and moving into implementation, and are running up against these challenges that we mentioned earlier associated with starting to collect data at enterprise scale. We have seen a number of companies be very successful using public IoT clouds in combination with a connectivity solution, and specifically using Azure IoT as their public cloud. And we hope that the material that Carl, Ray, and Neil presented today gives you a better sense of the different options for connecting or for using those technologies in tandem, and for quickly or as quickly as possible collecting data and start using these technologies to really drive value. For anyone who's interested in learning more, there are how-to guides for specifically how to connect these some of these products together on Kepware.com in the resource library, and certainly lots and lots of resources on digital transformation, the value thereof, and Thingworx on PTC.com. So I think with that, we want to open it up and give a few minutes for questions. So Kevin, I will pass it back to you.
Well, thanks, Jeff. As Jeff mentions, our presenters are now available to answer your questions. Please type them in the Ask a Question box on the screen. We will get to as many as time allows. Answers to the questions that we do not get to today will be posted online with the archived version of this webcast. Remember to download the Certificate of Completion, a copy of the presentation, and other resources. Use the Event Resources tab on the left side of your screen. Jeff, my first question from our audience is for you. Are you able to provide a specific example of a company whose IoT project was derailed because of challenges related to operations technology connectivity?
Yeah, absolutely, and it's a good question. We went into kind of some of the technical reasons that it's difficult, but there's lots of data out there talking about how this challenge has stymied a lot of projects. I think there's a McKinsey report saying that 85% of projects spend over 1 year in pilot without scaling, and that the key or one of the key reasons for that is kind of the heterogeneous environment that I referred to, as well as the difficulty getting machines connected. And in terms of a specific example, we were working with a company that was trying to get connected to injection molding machines, many of which use a protocol called the Euromap protocol, which is, it's notoriously, some of the older versions are notoriously difficult to work with, and the protocol hasn't necessarily been implemented in a standard way by all of the vendors who are making injection molding machines. And so we saw that company, I believe it was over a year that they had struggled with getting basic connectivity to their machines, and they still only had read-only access and weren't able to read as many of the parameters coming off the machines as they would like. And so we worked very closely with them. The product has a Euromap 63 driver, and within a matter of, it was really hours, we were able to get connected and get much fuller access to the parameters on those machines. So I think, I guess it wasn't a full, it was a derail of that project, but once they started to bring in a third-party tool versus kind of banging their heads against the wall internally, they were able to reset and start to make progress again.
Thanks, Jeff. Another question for you. Can you elaborate on why using a software development kit for operations technology connectivity doesn't scale?
Yeah, absolutely, and yeah, probably didn't go into as much depth on that as I could have, but it really, and I probably just mentioned that the key issues are maintainability and some of the other complications that I mentioned in terms of how difficult industrial protocols are to work with. But to kind of elaborate on that point around maintainability. An SDK, it really just allows you to build your own custom application, which you then have to support and maintain. And it's not just building one application. Every new connection that you need to make will require an additional application or a amendment to the original application. So when you start to think about the complexity of that, and just in terms of support burden, what we really see is companies that build their own connectivity are not supporting those solutions, or they're pulling off engineers from other critical projects to come back and support the the connectivity applications that they wrote. And I think, probably it's in many cases, there's, hey, well, an organization could say, hey, we don't need new features. It connects, and it's fine. But this is, we're talking about IoT connectivity. We're talking about taking the most critical production information in your facility and sending that through, sending that out over public, sending that to a public cloud. And, so the security aspect becomes really critical. And so you have to maintain those connectors, because any software that is, goes stale for a certain period of time, probably less than 2 years, starts to rely on out-of-date libraries and those types of things. So with, where in the past it may have been okay to build a connector and then just leave it because it's working, in the current environment, that's really a practice that we need to change. So sort of a long-winded answer, but security and maintainability are the two major challenges beyond just the difficulty of getting to know some of these pretty esoteric protocols.
Well, thanks, Jeff. Neil, a question for you. Does IoT Hub compete with Thingworx?
No. So IoT Hub is an ingest pipeline for the Azure cloud. It securely pulls data into the Azure environment and has the ability to manage devices. Thingworx, though it does have the ability to ingest data directly, it also is significantly more than just a data pipeline. So there is a slight, I would say, overlap in a feature of Thingworx when you leverage IoT Hub, but there's a significant advantage when you're leveraging IoT Hub in both the ability to scale horizontally and the ability to scale from a security standpoint as well.
Great. Thanks, Neil. One more question for you, Neil. Is bidirectional communication between Thingworx and Kepware possible when using IoT Hub?
It is. So that's something key is because we're using the IoT gateway, we're able to do bidirectional communication over the MQTT messages. The topics just have to be formatted correctly so those messages can be received.
Thanks, Neil. Ray, a question for you. Can the IoT Edge, we discussed the 3 different options for making those connections. Can the IoT Edge in option 3 handle both OPC UA and MQTT connectivity simultaneously? Neil, are you on mute by any chance? Let's move on to question 10. Carl, how can I estimate effectively the billing for sending data to Azure? How can I build the data stream for sending data to Azure?
Yeah, so to estimate the amount of data that you have, Microsoft has a bunch of guidance in docs.microsoft.com about this. And what it comes down to is you need to know the size of your messages, the number of messages that you plan on sending, and then you also need to know the size of your IoT Hub. There are 3 different sizes, small, medium, and large, and each of them have different throughput capabilities. And once you know the size of your message and how many you are, we have guidance on calculating how many messages that can be sent through. With the largest one, you're capable of millions of messages a second, though. So that shouldn't be a problem, or should be the limiting factor in calculating it. That just helps you understand how much that you're going to have to allocate in the IoT Hub to make sure that it can handle your throughput that you're planning.
Thanks, Carl. Ray, we're back to you. As we asked previously, with option 3 in the presentation, can IoT Edge handle both OPC UA and MQTT connectivity simultaneously?
Yeah, it certainly can. And sorry about the double mute on that with my setup. But the UA capabilities that we're talking about are leveraged through a module that's running within the IoT Edge runtime. So to get sort of technical, that's one of the container modules that's going to be running and active within that runtime environment that's connecting to an OPC UA server. In parallel, that same IoT Edge environment can also work as the transparent gateway that we discussed in option 2. So MQTT data from Kepware can be facilitated through that Edge runtime up to the Azure IoT Hub infrastructure as well. So those options are not mutually exclusive. They can be used jointly together in an environment.
Thanks, Ray. We're approaching the end of our broadcast time. I've got maybe time for a couple more questions. Neil, does Thingworx have all the visualization tools in it, or are you using something else to do the dashboards?
So Thingworx actually does ship with a visualization ability to create what we call mashups, which are HTML web pages through a drag and drop editor. So we have the ability we have our own visualization, and I would say it's visualization with the ability to do two-way communication, so you can add in stuff like user text input boxes and switch buttons. But we also can send that data off to other third-party dashboarding tools if required after context has been added.
Good, thank you. Jeff, the final question for today is to you. And just briefly go again over the change in the product lineup that's been introduced today, and just tell us what you think is most interesting about it.
Yeah, absolutely. So as mentioned, Thingworx Industrial Connectivity is now Thingworx Kepware Server. And I think it's interesting for a couple of reasons. One is that we're reintroducing the Kepware brand into the name of the product, and that's really, what we've seen is there's, as IT and OT converge. I know I mentioned that IT folks are oftentimes taking the lead on these projects and CIO offices, but what we're seeing a lot of times is cross-functional teams collaborating to make this real. So I think we are seeing some recognition of the value of Thingworx in digital transformation, because of Kepware in digital transformation. It does have a spot to play there. We also want to highlight, with combining the Thingworx and Kepware names, that they do work seamlessly together, also in conjunction with Microsoft, and the Thingworx brand really denotes, and sorry to dive deep on branding, but it definitely denotes leadership in digital transformation. So really what we're trying to say is, hey, with the combination of Thingworx and Kepware, we are accelerating digital transformation for our customers. And whether or not you're familiar with Thingworx or you're familiar with Kepware, the two solutions are really working together, as you saw here, as you saw in the demo, to deliver that transformative value that I talked about earlier.
Well, thanks, Jeff. To the audience, we've got a sudden rush of questions right at the end of the Q&A period. As we mentioned, the answers to those questions are going to be posted with the archived version of the webinar. But thank you for the great questions. And I'd like to say thanks again to our speakers, Jeff, Neil, Ray, and Carl, for sharing their time and expertise. I'd also like to extend special thanks to our sponsor, PTC Kepware, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it, because we use this information to improve our webcasts. Finally, on behalf of Control Engineering and PTC Kepware, I'd like to thank you for attending. That concludes our broadcast, and thank you, and we'll see you next time.